Hello students, welcome to Nirupal Tutorials. Today we are going to study the matrices part 2. In last lecture of matrices, we have studied the definition and the type, how to represent the matrix, what is the number of rows, columns, how to write down the order of the matrix, and then we studied the types of the matrices. Okay, a row matrix, column matrix, rectangular matrix, square matrix, diagonal matrix, scalar matrix, identity matrix, okay, which is very important. We can say as a unit matrix, which is a diagonal having only 1, 1, 1. Okay. Next, zero null matrix, determinant of the matrix. We studied how to find out the determinant of 2 cross 2 matrix. In next video, we will study the how to find out the determinant of the 3 cross 3 matrix. Non-singular matrix when the magnitude of the matrix is not equal to 0. Okay. For singular matrix, magnitude of matrix is equals to 0. Triangular matrix, there are two types: upper triangular matrix, lower triangular matrix. Transpose of the matrix, that is, we say the ulta pulta, that is if the r cross 3, the order is 2 cross 3, then the order of a dash or a transpose is 3 cross 2, and we have to represent, we have to write out the row as a column, and we have to write down the matrix in that. That is called a transpose. Symmetrical matrix, okay, and skew symmetric matrix. Okay, in matrices part 2, we have to study, we will study the construction of the matrix and then algebra of the matrix. In algebra, we will see only the addition, equality of the matrix, addition or subtraction of the matrix, and scalar multiplication of the matrix. Multiplication of the two matrices we will see in the next video, because it is very tedious process. Okay, and it is very hard to understand. So we will do only a single video on the multiplication of the two matrices. Okay, with maximum number of examples. Okay, so first for the construction of the matrix, we will take one example. Construct construct a matrix. Okay, A of ij. It is a representation 3 cross 2. The order is 3 cross 2, whose elements A of ij are given by A of ij. It is a formula given by I minus j the whole square on phi minus I. With this formula, we have to find out each and every element. So first we will represent the matrix. Let A of ij 3 cross 2. So we will represent like this. Okay, so number of row is 3, number of column is 2. So this is R1, R2, R3. C1 and C2. So this position is known as A of 1, 1. This position A of 1, 2. This is A of 2, 1, second row, first column, second row, second column, A of 2, 2, A of 3, 1, third row, first column, A of 3, 2, third row, second column. Okay, the formula is given as that A of ij is equal to I minus j the whole square upon phi minus I. To find out the A11, okay, so I is equals to, we'll take I is equal to 1 and j is equal to 1 as the position is 1, 1. Okay, so by the formula 1 minus 1 square upon phi minus 1, that is equals to 0 upon 4. The answer is 0. Next, A of 1, 2. So I is equals to 1 and j is equals to 2. So 1 minus 2 the whole square, okay, upon phi minus 1. That is minus 1 square 1. That is equals to 1 by 4. Next, A of 2, 1. Okay, so 2 minus 1 the whole square upon phi minus 2. That is equals to 1 by 3. Next, A of 2, 2. 2 minus 2 whole square upon phi minus 2. That is 0 upon 3. That is equals to 0. Next, A of 3, 1. Okay, that is 3 minus 1 whole square upon phi minus 3. That is equals to 4 by t upon 2. And then A of 3, 2 is equals to 3 minus 2 the whole square upon pi minus 3, that is equals to 1 by 2. Okay, so these are the elements. So the A is equal to A11 is 0, A12 1 by 4, A21 1 by 3, A22 0, A31 2, and A32 1 by 2. Next, we have to study the algebra of the matrices. The equality of the matrix must be given as order must be equal. Order must be equal to the given matrix. Second, corresponding element must be same. So A we will take an as A is equals to, suppose 15, 14, 12, 10. The order is 2 cross 2. For B, 15, 14, 10, and 12. Order is 2 cross 2. And C is 15, 14, 12, 10. Order 2 cross 2. Okay. So over here, so if we match by the coordinates, so 1, 1, 15, 1, 2, over here 14. 2 1 coordinate is 1 2, but over here 10. Okay, 2 2 o coordinate over here 12. So A is not equal to B, but if we check out A and C, it is equal by the coordinate also, by the order also, and by the coordinate also, by the element also. So A is equals to C. So this is known as the equality of the matrices. Same for 3 cross 3. Addition and subtraction of this, it is very easy. So A plus B, if we're taking an addition, so we have order must be equal. For the addition, order must be equal. Okay, in that matrix. Okay, if you want to do the addition, order must be equal. So 15 plus 15 30, 14 plus 14 28, 12 plus 22, and then 10 plus 12 22. Okay, so next for subtraction, so 12 minus 10. Okay, so for the A minus B subtraction, 15 minus 15 0, 14 minus 14 0, 12 minus 10 2, 10 minus 12 minus 2. Multiplication of the matrix by scalar. If A is any matrix, okay, A is any matrix, okay. So if A is any matrix, A of ij, okay, A of ij, okay, given order n cross m, and K is a scalar. So if we say K into A, so it is represented as, okay, K inside A of ij, matrix m cross n. For example, say we will take an as 3 2 1 0 5 and minus 1, and k we will take as a minus 2. Okay, so k into a, first we will represent this as minus 2 into 3 2 1 0 5 minus 1. This will give you, you have to multiply each and every element. So minus 2 into 3, okay, minus 6, minus 4, minus 2, 0, minus 10, minus 2 into 1 plus 2. Okay, and there is no issue of the order, as this is 3 cross 2, 3 cross 2, 3 cross 2. Clear? Okay. So that's it, students. In next lecture, we will study the multiplication of the two matrices. Okay, please do like, share, and subscribe.